Hello again, this is a geometry video and the topic is congruent polygons. Let's begin with this, a biconditional statement. Polygons are congruent if and only if their corresponding angles and sides are congruent. So we could make two true conditional statements out of this biconditional. Here is our given polygon. Notice all the markings and letters. Here is its match. This is a congruent polygon with the given polygon, and all of the corresponding sides have appropriate marks. Angle A is congruent to angle F. Side CB is congruent to side HG. Now when you are naming corresponding parts of congruent polygons and making congruent statements with them, be very careful because order does matter. In this statement right here, segment CB congruent to segment HG, the vertex C has to correspond with vertex H if that's the order that I'm going to write it. And likewise, vertex B has to correspond with the letter I put second to conclude my congruent statement. Now here's a little cautionary reminder for you. When we look at this first reflection, keep in mind that this is an easier problem to examine. Be careful and watch out for multiple transformations in a problem which are designed to confuse you, like this, which is reflected and rotated. If they're given as congruent, it can be harder to determine the order of the letters when you're making congruent statements. So just take a little extra time when there are multiple transformations. For triangles, there's a very important phrase, which is the title of this slide. It says corresponding parts of congruent triangles are congruent. And we are given congruent triangles. And remember that the order of your statements are very important. The corresponding vertices have to be in the same order. Okay, let's name all of the pairs of corresponding and congruent parts. Here are all of the correct answers. I'm sure you got them. And once again, here is our new abbreviation. cpctc will be a reasoning step in geometry proofs. And that stands again for corresponding parts of congruent triangles are congruent. Now while we have this pair of reflected congruent triangles, I want to demonstrate something that is also mentioned on page 223 in your book. In addition to rotations and translations of congruent polygons, it is a common thing in textbooks for these to overlap. Now this is a much harder situation to examine when we're given a congruent statement and the triangles are overlapping. It's easy to mix up. So when you are faced with a problem like this, my advice is create a second sketch and separate those overlapping polygons. And that will make it a lot easier to come up with all of these congruent statements. The last slide is topic is similar polygons. And what I have here are similar triangles. I've constructed a slider according to the ratio, and the ratio is called a similarity ratio. And you can see in the measurement of AC, and the corresponding side to AC is DF. These sides are proportional by the similarity ratio. So right now the ratio is 3. That means that this segment is 3 times longer than this one. And we can see that in the measurements. As I slide this slider to 5, notice that the ratio has been applied to AC to get DF. Angles do not change. They remain congruent. The sides are the proportional pieces. Thanks for watching. Keep practicing.